Let's now discuss the other two scenarios where the implementation of counter increments is incorrect. Let's now go back to here, and then let me talk about the first version of incorrect implementation. Okay, but before that, I would like you to do the following exercise, which can appear in your exam or in the written test, so you can think about it for yourself. Okay, so here is a question. Let's say I want this particular console printout to actually happen, meaning that it's going to be printed out from the outer catch block, and it will say value too large exception is thrown unexpectedly, meaning that it should be originated from either this or this or this, right? It cannot be from this, because if it was from this, it would have been handled by this try and catch block already, which can never reach this catch block, as I discussed in the earlier video, right? So my question is, can you somehow make invalidates to make this implementation incorrect, maybe by changing it in some way, so that when I try to execute either this or this or this, I will end up getting to the catch block with this printout? So that's my exercise for you. Pause the video and think about it, how you will change it. All right, assuming that you have thought about it, one possible incorrect implementation to result in this error over here would be, let me write it down. Rather than equals over here, it could be just strictly less than, meaning that if the value of the counter is strictly less than the counter maximum, we are actually going to throw the value too large exception in a way that's premature, right? Let's see exactly how this could be the wrong implementation, and then we're going to see the execution flow in both the paper and the Eclipse. Okay, let's try to see that. Okay, if we do this, let's see. So if we do strictly less than, so we're still going to initialize the counter value, and then its value should still be 0 to begin with. So far it's okay, right? And then we're going to execute the outer try block, and then we're going to, let's say, execute the first C dot increments. At this point, we know that the counter value is actually 0, right? And then when we try to say increment, let's step into it. So step into it, and then executing this if branch, we're going to evaluate the value over here at the point we set is going to be 0, and counter the maximum value is actually 3, as always. So now 0 less than 3 apparently is true, meaning that we're going to throw that value too large exception prematurely, right? So that means as soon as we are finishing this method call, as soon as we are executing this increments over here, we're actually going to bypass the rest and go directly to over here, the catch block, which has the value too large exception, right? So that means we're going to bypass this, and we're going to bypass the rest of the try block. Also, and also we're going to bypass the incomplete inner try and catch block. We never get to it, right? And then bypass the rest of the try block. And then once we execute this catch block until the end, and then we're going to execute the main method over here. So that'll be the execution flow for this exercise over here. Hopefully, you came up with some solution that's kind of similar to this line of thoughts that will actually generate the incorrect implementation. All right, hopefully that's okay for you. And then let's now talk about Eclipse quickly. Let me just go back to show you how you can reproduce the experiments, which is also very important. Let me clear the console over here, and then I will simply go back to the counter class, right? You will see under the increments, I got 2 different changes for you to make, and this is the first one, okay? Let me temporarily change this from equal to less than. And by the way, this is what I changed from earlier for the decrements. You may just want to put it back, so that's correct implementation. You can always change them to a correct or incorrect implementation just to play with. Okay, let's go back to increments. For the increment, this is apparently it's a incorrect implementation, and let's now go back to ConsoleTester2, and let's now launch the debugger over here, right? ConsoleTester2, and let me switch to debug perspective, and then let's now step over. Step over up to this point. You can see if I move my cursor over, the value of counter is initialized to be 0. As soon as I say C dot increments is explained before, it's actually going to throw that value to large exception prematurely, right? That's something we said. And rather than stepping into, which you can do as an exercise on your own, I'm going to say step over. Can you anticipate what's going to happen? Well, apparently it's going to throw the value to large exception, meaning that we're going to follow the abnormal execution path. We're going to bypass the rest of this particular try block. Remember, this is one line of the try block, one line of the try block, outer try block, I meant. There's one line of the outer try block, and think about this is a single try and catch statement of the outer try block. So that will be bypassed as well. So the rest of these will be bypassed. So if I try to say step over, and then I'll go into the catch block, right? So that, and then I'm going to print out error value to large exception. And so what's the value of this result so far? So that means if my implementation for the counter was implemented incorrectly, right? The increment method was implemented incorrectly. In that case, my tester over here can correctly tell me that it was actually incorrect because the value to large exception was thrown unexpectedly, right? So that's something to really keep in mind. Don't lose the big picture. Let's now talk about the other incorrect implementation, right? And as before, I'm not going to post the exercise to you. You want to pause the video and think about it. Let's say we want this particular error to be printed out to the console. Can you somehow modify the implementation for the increment here to be incorrect so that the execution flow will lead you to this particular error message printout? So that's the exercise. All right, pause the video and think about it. Assuming that you have thought about it, let's see what the error could be. Okay, so one possible case could be, rather than having equals over here, I can say strictly larger than equal. Intuitively, that simply means I will only throw this particular value to large exception when the current value is strictly larger than maximum value. Strictly larger than 3, meaning that when the counter value is currently 4, I'm going to throw the exception when you try to increment it. But what if it's already 3? In that case, 3 strictly larger than 4 is not the case. So that means you wouldn't throw the exception as expected. All right, so let's see what the execution flow will be. So what's going to happen is, let me just use this. So we're still going to initialize the counter. Counter value will be just 0. Execute the try block. And then we're going to execute c.increments, c.increments, c.increments. And just don't forget the value of the counter for each one of them. Before this one is executed, counter value will be 0. And then 0 larger than 3 will just be false. So we don't really throw the exception. We don't, right? And similarly, before the second increments, it will be 1. Before the third increments, the value will be 2. So 1 larger than 3, 2 larger than 3, all of them will be false, right? All of them. So that means we don't throw the value to large exception. And then we're going to print out current value over here is going to be 3. Okay, so far so good. And then we're going to execute inner try and catch block. And then when we try to do c.increments over here, what's going to happen? When we try to do c.increments here, let's step into it. Let me just do a different color. Let's say when we do this, let's now use orange. So when I step into this method over here, so now when I execute this branch, what's going to happen is it's going to be value being 3, and then the counter maximum is remains to be 3 as always. 3 larger than 3 is still going to be false, meaning that even though we are expecting some value to large exception to be thrown at this point, but it will not be because we got false over here, right? It's really important for you to see that. Okay, so this part here will still be actually false, meaning that we are not going to throw the exception. Instead, we're going to mistakenly increment the value from 3 to 4. So 3 incremented to 4. So after this is going to be value 4 for the counter, which is unacceptable. And then we're going to print out the error over here. And what's going to happen after this? So we are following the normal flow of execution. And after we get to the end of the execution flow, let me just switch back to pink just to indicate the execution flow. After this, we're going to bypass the catch block since the exception never occurred. And then we're also going to go to the rest of the try block over here, okay? Just normal execution flow. And then we are also going to bypass the catch block over here because as far as this catch block is concerned, let me remind you quickly. This catch corresponds to the try over here, and as far as it is concerned, you can see this one, this one, this one, this one here, and also the try and catch block over here. As far as what I'm highlighting, what I have highlighted here is concerned, they have not thrown any value too large exception. That's why it will never be executed, right? And then after this, I'm going to execute the end of the main program, and then the program will terminate. All right, so that's about the conceptual trace of this third case, which I hope you actually came up with some similar solution that will give us the same execution flow here. Let's now try to experiment with this on Eclipse. Let me go back to our counter class over here. So rather than less than, let's just try another incorrect implementation, larger than, right? And then let me go back to counter tester over here. Let me launch the debugger once more. If I do that over here, okay, let me just stop it. Somehow it did not launch properly. Let me just try again. If I say launch the debugger, okay, very good. Yeah, sometimes if it didn't really launch properly the first time, you can simply stop the debugger and try it again. All right, anyway, let's try. So now step over, and remember, the increment will not actually throw any exception prematurely. So 1, 2, 3, and here. At this point, you can go move your cursor over. The value of the counter is actually 3. And when you try to increment the value when it's 3, it should be some exception thrown expected. But in this case, the implementation is incorrect. What's going to happen is, if you recall over here, let me just try to show you here. So if I step into here, you can see this counter value is actually 3, and the maximum value is actually 3. 3 larger than 3 is going to be false. So if I say step over, I'm going to bypass the throw new exception, so never occur, even though it is expected to be. And then it's going to increment the value of counter from 3 to 4. So now if you move your cursor, if you examine under this, the value has been 4, which is unacceptable. If I step over again, so you can see after executing this method, no exception has been thrown. So we go over the normal execution flow. And then we're going to print out the error over here. Okay, that's going to be error value too large. Exception was not thrown as expected. And then after this, we just go to the end of the try block, right? And then we're going to bypass the catch block over here completely. And also we're going to bypass this catch block completely as well. We just don't execute it. Right? And then we just go to the end of the main program, right? Again, you want to understand very well why this inner catch block was bypassed, and also why this outer catch block was also bypassed. You should really know the exact reason, which are different for each one of them. Okay, so let's now stop the debugger and then switch back to Java perspective. Right? So for the second example over here, I'm going slightly faster than the first one, but I'm still being quite detailed about what you should really know. You really want to review console tester number 2 and also console tester number 1 that we spoke about earlier. You want to make sure you really understand the design for these two test cases. Even though they are using console application, which is not perfect, but we will try to improve them by using JUnit test cases later. And the logic will just be identical. It's just that we gotta replace, rather than printing out error line to the console, we're just going to use some special assertion in JUnit called fail. That's something we'll see. All right. Let's now see more examples.